This is a question from Professor Richard Golden, and he's asking basically for a comparison or a contrast between our path model and David Marr's sort of levels of analysis idea. And I think they don't have to be seen as alternative or complementary, because they could be either or both, depending on what how the individual scientist wants to see their work. So I think it's possible to have a path model that can be analyzed itself using Marr's levels, and then the opposite too. So having within one of Marr's levels, like say the computational level, have a path model to describe the research being done within it.
Yeah, so I think our answer to that is that you could overall say that our proposal is complementary to Marr's original proposal, but that as we've both just said, that you can apply our path model to each level, so at the computational level, algorithmic level, and implementational level. Because improving clarity and being explicit about how formalism and specification apply at each of those levels is equally important in all of them. So
yeah, exactly. Also, I think and other people have said the same thing, is that Marr's levels are not the be all and end all, right? You can have more levels to further subdivide Marr's approach. And I think there's also this inbuilt hierarchy in Marr's levels too, which is good. It's just that our path model doesn't really strongly, if there is any hierarchy in our path model, it's a dynamic hierarchy that is just sort of temporal, right?
Yeah, I think it's, yes. And I think it's also that more and more, I mean, when I've engaged with Marr's theories of the levels, more and more we see that there's like mutual constraint between them, right? So
yeah,
if you want to come up with a computational level theory, but you want to a priori say, look, I want one that can be realized with an implementation based on biological neurons versus artificial ones, then I might have different constraints. And if you want to be aware of that already, then you develop the computational level theory given those constraints. And I think that actually an action like that falls within what we're proposing within the path model, that you want to have temporal constraints and where you're considering these things, but that they feed back. So you are able to develop a computational level theory that you know has properties that allow it to be instantiated by a neural system.
Yeah.
Of course, you can also say, well, I'm not interested in that. That's not what I'm trying to explain. And then you don't do that. And that's also legitimate.
Yeah, exactly. And I also think that with having more than one way of thinking about, doesn't have to be like Marr's and our path model, but zooming out even more, having more than one way of thinking about how you carry out your research or how your research fits into the broader picture, having multiple ways of thinking about that is probably really, really useful. So even the idea that like things, how would we call them, like overarching meta-scientific understandings shouldn't be mutually exclusive, at least in my opinion. It should be that you should be able to like, how can I put this, like shuttle between or entertain at the same time different ways of seeing how you fit in or how your work fits into the broader field. So I think if you like thinking of your work from the perspective of Marr's levels of analysis, then you should also be comfortable, or at least interested in situating yourself in our path model too, and so on, for other ways of thinking about that, because I think is probably the only way to really get to a kind of freeing, or how can I put this, like very, very general understanding, because basically you start to model how other people situate your work too, and not just how you would like your work to be situated, if that makes sense. Mm-hmm. So this is a question from Dr. Jana Jarecki. I hope I said your name correctly. So the question is, if we see a hierarchy in our path model, or if you conceptualize it as a single level, the upper parts, framework, etc., have some sort of hierarchical relation. So when they say upper parts here, I'm assuming between sort of framework, theory, specification, implementation. And this is my guess, and I'm assuming when they say lower parts at the same level, I'm assuming they mean hypothesis and data. I'm not entirely sure, because however we do this division, I don't think that it's true. So I think this helps answer the question, which is that I think each of the levels in our path model, each of the steps in our path model is has a sort of, how can I put this, encompasses or entails infinitely many of the steps directly below. So that could be seen as a hierarchy, if that's how you want to use the word hierarchy. But definitely I would push against the idea, and I think I have in other situations when I've discussed this, I would push against the idea of using the word hierarchy if what we mean is that there's like a primacy, or that there's like this needs to be done first. Because
yeah,
sorry, go ahead.
It's not a value judgment that one level. Yeah, so it's not hierarchy in that sense, but maybe hierarchy or directionality. I think of it more as directionality.
Exactly.
So strong currents of information flow downwards, right? Because you really want the work that you've done at formalization to influence what specification you choose. In fact, it has to, right? You can't specify something that you haven't formalized to some degree, but you can also realize while you're specifying it that your formalization was insufficient, that it wasn't explicit enough, because you can't choose between one specification or another, which means you return to the formal level to do more work such that you can work more efficiently or easily or unambiguously at the specification level. So in that sense, I guess there's that directionality, but there's no hierarchy in the sense of value of one level above the next, because we don't want to be interpreted as saying that data is on the lowest rung, or that framework is on the highest rung in an ontological sense. It's just more about how information or work done at each level impacts the next, and there is a directionality in that. But part of the claim is also that we have to use stuff that we've learned at a subsequent step to sort of recur back or flow back to inform work either in another pass or in a future version of the model earlier on, right? That's how we build theories in general, right? We build theories either by abduction or by basing them on things we know about the world to begin with, right? So that in some sense means already that data is feeding back to theory.
Yeah, exactly. And also I think what you just to underline what you just said, and kind of one of our points is that the connections between the levels are bidirectional for a reason, and that's because you can start out if you want, and I would argue it's almost impossible not to think of it this way. At some point, you will start out with literally just noticing that something deserves to have a theory, right? Noticing some anecdotal data and thinking like, oh, well, this deserves to be turned into, a verbal description of what I'm seeing. And I think that's, in my opinion, that's the important proposal in our path model that I haven't really seen other people flesh out in this same way, which is that that you can argue there's a temporal hierarchy, but what we're saying is it's flexible. You can enter the path at any point. So I would be okay with people saying there's a hierarchy, but it would be research program specific. As in this research program, we started off looking at the data and like really scratching our head and thinking, and moving upwards and whatever, formalizing a computational model. Because also I think that one of the questions I get really often is, this is all great, but how do we start? We don't have a theory. I don't have a theory for this phenomenon. I want to collect data. And my answer is, our answer is that that's completely fine. Go off if you want and do that, but think about moving back upwards and starting to integrate what data you've collected into a theory. So I think that's kind of like why the word hierarchy can be both confusing but also appropriate. And the other thing is, just to go back to the actual question, I think that thinking of things like hypotheses and data sets as being on the same level can be a little bit too reductionist, because I think that even the simplest hypothesis can have infinite data sets collectible to test it, right? So I think that's an important thing to bear in mind, because thinking of data sets as being uniquely related to the hypothesis which they test can also be too simplistic, right? So when we've changed our minds and realized that, you know, the theory that generated the hypothesis that we tested is completely flawed, that doesn't necessarily mean that the data collected to check that is useless. So this is a question by Professor Gerrit Full, and I hope I've said your name correctly, about thinking about where one's philosophy of science comes in to understanding essentially the steps in our path model, and saying that at each step the assumptions may increase. And this is completely in line with what we believe, and it's also why in the preprint we mention that the principle of multiple realizability holds. So each time you move in downwards in our path, as in towards the data, you have infinitely many possibilities to you know, collect data, for example, or to generate hypotheses and so on. And that is, in our opinion, completely fine.
So these steps are implicit. We rarely actually write down that we're doing them.
Yeah.
There's all sorts of implicit assumptions at each step that we before this, we weren't even writing down that we were doing.
Yeah.
We've at least written down that these are the steps that we're doing. There can be more.
Yeah.
But now for each step, you have an opportunity to say, what are my assumptions at each step that I take? Yeah, this is all about deconstructing our assumptions and how they affect what we conclude in the inference process. That's exactly what this is. I think the last thing I'll say is that part of the motivation for us writing this down is that we felt that before, without even writing down the steps, that we all tacitly take these assumptions that we were talking about actually accrue at a faster rate and more sort of surreptitiously, in the sense that whatever one's philosophy of science might be, if it's influencing your decision at each step, but you're not writing those steps down and not evaluating the effects that the steps have on each other, then you're in a worse situation with regard to your awareness of your assumptions. So
this question is by Ricky Romeo, and I think the only part that I would disagree on, right? Because I think this is a good question. It's a good like conceptual extension of the simple example of the pizza model. But the only thing that I would disagree on is that it you know, it leaves us in a pickle. I don't think this is a pickle.
No,
I think
exactly
this is normal science.
Yeah.
And I would almost, it is possible though that it could lead to the different research programs disagreeing with each other, right? Because obviously
the programs are just about fundamentally different things. So one is experiencing the fullness, and the other is about like the quantitative measurement of pizza consumption.
Absolutely.
And that actually links back to be explanations for different things. They're not explanations for the same thing. So even
exactly.
that you're both trying to ask the same research question, you're actually asking different research questions, which means you've already diverged on the path further up before you got to this level. Secondly, I think the leaving in as a pickle part is a consequent of the premise, if we accept that measuring proportion instead of Likert ratings is more akin to a model. And that's something we would just completely reject, right? We don't think either one of those is more a model or not, right?
Exactly.
So a Likert scale is a measurement, but you could certainly make a model that was based on Likert. You could have a Likert-based model of the world, in as much as you could have a proportion-based model of the world or a proportion-based measurement. So
absolutely. I think also this ties into, if we think back to the pizza problem as formulated in our talk, we essentially already have this, right? Because there are people, including, you know, most people, including myself, who would have originally assumed that the two pizzas were more food. So I think that's exactly where the computational modeling can come in and nail down. If you do want to go that way, where you define the two pizzas being more food, then you cannot base that model on the mass of the pizzas or the weight of the pizzas or the surface area of the pizzas,
but I think
or whatever.
What we say in the paper, where, you know, if you want to maximize surface area of the pizza, you're going to make different choices than if you want to maximize sauce, you know, a quantity, right? So because then if you maximize surface area, you have more crust with less sauce. So these are trade-offs that are actually expressions of what it is you either want to explain, test, or what your or expressions of what your assumptions coming into that you haven't fully worked out or explicitly listed in your framework or in your verbal or formalized theory. So it's actually just a sign that you are well on your way within the path model production system, and maybe need to float back up a few levels to specify something some more.
Exactly. And also I think it's important to remember that these issues, like what this is being seen as an issue, is exactly where if you mapped out all of these things on the path model, you would start to see that they're actually following a different path, and that's actually completely fine. It's the problem, the pickle is when you don't do this, whether you're using our path model or some other way of mapping out your research program. The pickle is when you don't do this, and when people, because these things happen and they can be pickles, right? Because people can get entangled notions and disagree, right? Where you have like one group of people saying, oh, this is more pizza, and another group of people saying this is more pizza, and one is like the Likert scale and one is like the mass, and it is a pickle. But the whole point is that the way you extract yourself from the problem, or the way that science can extract itself, is literally by saying both of you are correct, because you're doing completely different things, right? So yes, I don't think this is an issue, right? I think the only issue comes in when you don't formalize, which is exactly what you just said.
Yeah.
And I think, yeah, so I think Chris Donkin said the same thing here,
okay.
You know, very in line with what we said, which is just that there are different explananda, right?
Yeah, exactly. No, that's exactly it. Yeah.
And I just said, yeah, this is completely normal.
Yeah.
And you can also, oh right, I made this other point that you can also move towards unifying them, right? So move towards having a unified theory that accounts both for the amount of food that you,
yeah, of course, that would be amazing.
So because essentially, I mean, my very simple understanding of this already simple problem is that the fact that the pizzas can be separated off into pizzas, right, versus being one big pizza, could probably also play a role in how you perceive it as different amounts of food as well. So there's so many things to like fit into if you wanted to create a model of how people rate their hunger
experience.
Exactly.
Well, all the talks raised valuable and important points. I think overall, if I had to summarize, I would say that for me, it just really highlighted how important specification of all of the levels in our model, and you've worked on this in the past extensively before, Olivia, that specification is really, for computational modelers, where all the action is. And if we don't take our time and do the work there, we'll just end up with all sorts of complicated and laden assumptions that we are not aware of. So I think that's just highlighted to me how important that step is, the formalism to specification step.
Yeah, I think it's one thing that pleases me about all of these talks is the kind of very zoomed out idea that there are modelers out there who really care about using their models to improve theories. And I think that there are, there's almost like, I don't want to say two groups of people, but there's two sort of schools of thought that people can orient themselves towards, I think, in modeling. Two large ones. I'm sure there's more than two, but one is, I think, that they see computational modeling as a kind of tool, or like a fancy add-on to an already existing, more empirical research program. And then there's people who, or there's this other notion that is about using computational models also as that, but more primarily as a way of understanding our own theories, improving our own theories. Exactly. And I think this is a really, how can I put this? I feel this is a real dichotomy between modeling, philosophies of computational modeling, because I don't agree that computational models only serve the purpose of enhancing or making more unique a empirical project. And I think that unfortunately, for many reasons, modelers get pushed into thinking that way or behaving that way. Whereas I think the real value of a computational model is so much more than that. It's basically to mediate between observations of the world and our understanding of the world. And I think that's so much more than just what a computational model can offer if it's just being used to enhance an empirical project.
Yeah, I agree.
So it's really nice this is completely personal, obviously, but to me, it's really nice to know that there are people, other modelers out there who see the value in theoretical work, and who also see the value of using computational models and orienting them towards kind of the more theory side of
as an expression and analysis of theory. Really, that's how what I need them for, in order to be able to access my own assumptions about the theory that I'm developing.
Yeah, absolutely. And I think formalizing models using maths and formalizing models using code is a really, really useful way of doing this. And I think, when I say that out loud, it really underlines to me the difference between people who just say, I'm going to computationally model this data.
Yeah.
Because both of these are compatible and useful and good, but quite often the emphasis is on the second one.
There's a way to use computational models as a form of a data model, right? And that's just a different function that doesn't have the same sort of analytical power, I think.
Yeah. So I think, my kind of general takeaway is just that there's a lot of interest and a lot of people thinking deeply about this, and I'm really
it's encouraging. It is
really encouraging. Exactly. Really grateful also to have been allowed to add our perspective as well. And I think I don't know how much this is being seen by people outside the modeling community and the math science community in general, because I think a lot of this is actually stuff that we need to improve within our own from modeler to modeler. I don't think, the marginalization, if that's not too extreme a word, of modeling, or the orientation of modeling towards being more subservient to empirical work is, necessarily a function of non-modelers. This feels like a lot of this stuff is, it's not that we brought it onto ourselves, but it's like we have to also show our work as being, what it could be, or the deeper value of it. We have to be able to promote that, and
we have to model that culture, right? We have to model or present that those set of values. We can't expect that those values just occur spontaneously without us embodying them. And that's true on almost every level of human existence, sadly.
Absolutely. And I also think that there's what's the right word? Not sins, but flaws sometimes in how we present ourselves, right? Because I think there's nothing useful about a computational model that no one outside the user base understands.
Then it's just a tool to intimidate or to express prestige with, and that's just
exactly.
That's worse than not doing it, I think.
Exactly. And not only is it worse than not doing it, but I think it's almost like it doesn't even do. It might not even within community, within user base, do what they think it does. Because improving a theory, right, it requires people who collect empirical data within that theory as well to understand the computational work, right? So I think it's like you create a hierarchy. You could, maybe that's why I'm so upset with that word hierarchy being used without, a more, I don't know how the right word, like a
judgment. So there's sort of
exactly.
a polysemy going on here with hierarchy, right? So
yes, exactly.